Hello and welcome to my presentation on microservices, Docker, and Kubernetes. My name is James Quigley. So a little bit about me. I worked at ResTech from January until about September of this year doing web development. I guess officially kind of my foray into web development started with Opportunity Hack in 2016, which I participated in, and again in 2017, participated in Desert Hacks, and also volunteered at SW Hacks. I'll be, continuing with those. I think there's a combination. I think Desert Hacks and SW Hacks are merging this year, so I'll probably be there, and I plan to go to Hack AZ down in Tucson in January. So let's get started. Microservices, what are they? A microservice essentially is when you take, instead of having a big monolith web application that just does everything, you split it up into a handful of other processes. So you pick discrete business logic functions, say maybe authentication or logging or user management, a very specific thing, and you put it into its own application. And those different microservices can communicate, since they're going to need to do that. And that's almost always done via HTTP. And you have to have well-defined APIs. And it's really in demand, which is why I'm talking about it. This is essentially the difference between a monolithic architecture and a microservices architecture. And on the left, you can see in the monolithic architecture that you have this is typically your three-tier typical architecture. You have the UI layer that the user actually interacts with. They click stuff, things happen. It triggers functions inside your business logic, which then uses the data access layer to communicate to a single database that stores all of the data, and the business logic is this giant beast that has everything. In a microservices architecture, you still have the one user interface that the user interacts with, but these actually trigger independent microservices, which, could have a shared database, or maybe they each have their own database and they all do a very specific function. So what are some of the advantages and disadvantages to microservices? Some of the big advantages are that it's language independent. Because these microservices communicate via HTTP, it doesn't matter what language is happening on the back end. As long as they conform to HTTP standards, they can communicate. So maybe one microservice is written in Java, another one's written in JavaScript, and another one's written in Go. You can do any language. It doesn't really matter. Another advantage is that it allows you to actually split up each microservice into its own team. So in an ideal workplace, in the monolithic architecture, you would have, say, 20 people working on this big project, and it's big and clunky and it gets complex. In a microservices architecture, you can put 3, maybe 4 people on each microservice. They're responsible for specifically that microservice and everything it does. They can pick the iteration cycle that works best for them. They can pick the language that works best for them, and it lets them work really fast and easily on a very specific business function. It also isolates faults and exceptions inside your program. So if one microservice fails, it doesn't necessarily mean that the entire application fails, especially if you are, practicing RESTful things, RESTful APIs. One microservice can handle another microservice's failure and respond accordingly to the user through the user interface. It doesn't have to essentially just crash the whole system. They work well with containers. You containerize a single microservice, which then makes it scalable. And that is really one of the biggest advantages to microservices, is that they're dynamically scalable at runtime, which when you're using cloud computing is so important, because on-demand pricing is expensive. It costs businesses a lot of money. So if you can scale down when you don't need as many instances running, you can save your company a lot of money by using microservices. So what are some of the disadvantages of microservices? Well, there's not too many, but they are pretty big ones. Complexity is kind of the biggest. you go from having a logically laid out, single application that you try to break down as best as you can, but it's one application, and you can kind of follow it and track it throughout there. In microservices, you could have any number of microservices communicating with other microservices. It's hard to trace a request from the point that it hits your main application. It bounces from service to service to service to service, hitting any number of databases, and finally gets sent back to the user. Maybe something goes wrong in that request, but where? Like, where did it happen? It's hard to trace. It's hard to figure out. There's also a lot of overhead in terms of knowledge. You need to know, the architecture, how you're going to organize things. You need, containerization, have to understand that. You need to know a container orchestrator, ideally. So there's a lot of overhead in terms of knowledge, but there's also overhead in terms of infrastructure. With a monolithic application, it's easy to just spin up one instance, grab a database, boom, you're good to go. It doesn't take a whole lot of infrastructure architecture know-how to make that happen. With microservices, there is a bit of overhead. You need to be able to dynamically spin up databases and servers. You need to be able to, containerize and deploy these things on the fly. So it starts to get a bit more complicated. But again, as we talked about in the previous slide, there's a lot of advantages, and a lot of organizations are thinking that those advantages are, more prosperous than the disadvantages. So I've mentioned containerization a couple times. So, what is that? Docker is the biggest and most popular container system. So it's a way to containerize your application to put everything that your application needs into a small image that can then be run on any computer that also has Docker on it. Docker is really powerful because it essentially eliminates the the problem that people always say, where it's like, oh, well, my program ran on my computer, but it doesn't necessarily run on yours. And, it's hard to figure out, well, why is it? Are you missing a library? Did you mistype a command? Did I change source code and I forgot to push that? Containerization, if I build a container and it runs on my computer, it's going to run on any other computer that also has Docker. This is Docker's definition that they from their website about what containers are. And a container is not a virtual machine. So that's kind of one of the big things that people kind of get confused. They're like, well, you're packaging an application in all the libraries, so you're just making a virtual machine and running it, and you just share this virtual machine. They share some of the same principles, but they are different. And it's a big difference because, as we can see in here, in a virtual machine, you have to package up an entire guest operating system into this virtual machine. You have to have all of the bins and libraries that are required to run your application, and then you actually have to have the app inside of it. So as you can see there on the left side, that's the virtual machine. Essentially, you would have your host computer on the bottom, and then on top of that, you're running any number of virtual machines as they demonstrate there. On the right hand side, you have the container. You don't have a guest operating system. Docker does all of the translation layer for you. Docker doesn't take up a whole lot of space on your hard drive, or it's not like a super beefy application. It just runs on your computer, and it runs a container, and all a container has is a definition of the bins and libraries that it needs, and then the actual application itself. Another one of the big things here that isn't really illustrated is that with Docker, containers can actually share bins and libraries. So if I'm running 3 applications, but they all use Node and Express because they're web apps, I don't have to have 3 copies of Node and Express installed. Those containers can share bins and libraries through the applications. So it really cuts down on size because you're not using a guest operating system, and you're not having to install bins and libraries independent for every container they can be shared. So image files, Docker image files, are actually very small for what they do. So it allows you to download them and run them very easily. And again, as I said, any computer that has Docker, if my stuff runs on it, it should run on any computer that has the same Docker also installed on it. So how do you create an image? Well, you have to define a Docker file. A Docker file describes the build process for an image. So it's a definition. It's not the actual program. That would be what the image is. The image can be run. A Docker file is just a definition. So it says, okay, well, maybe my application is going to be based on Node. And so I declare, all right, base it off of Node, copy my files here, run npm install, and then, the main command that will be run is npm start when you actually run this image. Docker file doesn't, do anything in itself. You can't run the Docker file. It doesn't run your program. It's a definition of how to build the image. So once you've written your Docker file, you can then build your program from the Docker file into an image, and that image can then be run on any computer that has Docker. So why is Docker important? Other than all of the other things that I've listed, here's some numbers that maybe might convince you of Docker's importance in industry. Docker did a little bit of research. These were provided by Docker. 71%, over 70% of organizations that Docker talked to are either currently using or will be using Docker to containerize an application, a legacy app, and 78% are going to be using it to build new applications. 44% of them are adopting microservices. So we're talking about a massive amount of companies looking for developers that know Docker, can use Docker, can build up a new architecture using Docker and microservices. And they're willing to pay a lot of money to get you there to do it. So important, and it's going to be super prevalent within our industry. So say we have a microservices architecture and we've containerized our applications. How do we run it? This is where the container orchestrator comes in. I'm going to be talking about Kubernetes just because that's what I have experience with. But on the right, you can see all of the different types of container orchestrators that are out there. Azure has their own. Amazon has container service. Marathon is another one. Docker Swarm. Google Container Engine actually runs like Kubernetes in the background. It abstracts it away from you, but it is a container engine. Or you can just run Kubernetes, as I'm going to be demonstrating today. So container orchestrators, Kubernetes specifically, essentially take a declared state of how you'd like to configure your microservices, your containers, and it makes it happen. And what's really cool is it makes it happen across computers. So in the cloud, let's say I'm running, in Amazon, or I'm running in Azure or something like that. I, boot up a couple of, compute instances, and I want to run my applications on them. I could individually go, SSH into each one, clone my application, build it, run it. Oh no, it crashed. I have to go back in there, figure out why it crashed, reboot it. Or I could use Kubernetes. I just set up Kubernetes on each of those instances. They'll communicate with each other through the master, and I can pass Kubernetes a deployment. I can give it a declared state that I would like, and it will make it happen. It will deploy my containers and make them publicly available, and it does a lot. So we'll get into it more than what it does, but it's very important. There's a bit of vocabulary, that vocab that you need to know for Kubernetes, just because there's a lot of different moving parts in it. So hopefully this helps figure some of that out. So essentially a node is an instance of a computer. It's running Kubernetes. So kubelet is the application that is running that communicates with the master node, and a node runs pods. A pod is a definition, and it contains one or more containers. You could have one container, you could have 5 containers running on this pod. So if I run a pod, I'm running however many containers inside it that are declared. And pods, again, are run on nodes. A service handles requests either coming from inside the Kubernetes cluster from one node to another, or from outside the cluster, say public request to our master node that wants to hit a specific service, microservice. So the service tends to be a load balancer. There's a couple different types that you can declare, but the service is essentially a definition of how requests should be routed and handled within the cluster. A deployment, as I said, defines desired state. Kubernetes does the rest for you. So I say I want 3 copies of this specific container. I want them XYZ, and Kubernetes just does it. So this is kind of how Kubernetes looks, a visualization of it. So you have your master that has replication controllers. Replication controllers essentially handle, making sure that there are, if I say I want 3 copies of a pod, the replication controller ensures that there are 3 copies of that pod. And it also contains like a history of how I change deployments. So if initially I say I want 5 copies, and then that's not enough, and I say I want 10, I could revert that and go back to 5. Or maybe I have version 1 running, and then I push out version 2, and something breaks. Oh no, I need to revert. I can quickly revert that to the past replication controller. It'll make sure that my version 1 is out there. The master also contains like the service definitions, so for routing. But as you can see there, this is a cluster that has 4 nodes and a master. Each node is running a certain number of pods, and each pod has a couple of containers in it. So this is essentially like a visualization of what a Kubernetes cluster would look like. Here's an example of a deployment file. You're allowed to use JSON or YAML. They suggest YAML because it's very human readable. If you haven't used YAML, it's essentially like JSON, but instead of brackets, curly braces, you use indentation. So Python fans rejoice. But it contains the declared desired state. So this would be a deployment file for Nginx. If you want 3 copies of Nginx 1.7.9 running on port 80 within your cluster, this is how you would do it. Within the YAML files, you can declare essentially any type of resource. It could be a deployment, it could be a pod, it could be a service, replication controller. You can create any of those within a YAML file and ask Kubernetes to create and maintain it for you. Kubernetes also does some cool things like automatic rebooting of pods if something crashes. It'll do things like rolling updates, where if I have version 1 out and I ask it to push out version 2, it will add version 2s, but it'll make sure to take down version 1s only when version 2 is available, so that there's no downtime. Even if I'm just running 1 copy, I can have version 1 running on 1 copy. It'll boot up version 2, and as soon as version 2 is ready, it'll take down version 1 and change the service to point to version 2, so that from the client perspective, there's no downtime. They won't even necessarily know that change happened, but it just does on the fly. And Kubernetes handles all of that for you. So it's so cool. So I'm hoping to show you guys some of this. All right, so let's break it down. First thing we're going to do is talk a little bit about Docker. I'm going to pull up a terminal here. Let's increase the font size. All right, so if you have Docker installed on your machine, you can see I do. You can see all of your current running pods by doing Docker PS. So right now I was messing with some stuff earlier, prepping for my presentation. So I have some running right now, but I'm going to kill those off so that we can start fresh. All right, now if I run sudo docker ps, I don't have any containers running. There's nothing going. The most basic thing you can do is docker run. So this is going to run a container. So now I have to tell it what container I would like to run. And I would like to run hello world. I think there's no dash here. This is just going to run Docker's hello world application. Just kidding, there is a dash. So here's the Docker basic hello world. It just shows you, all it does is just print this out. So we'd like to do something a little bit more complex than this. So there's a container called also hello world, but by Tutm, I think, tutm/hello-world. And it's another hello world file, but it actually runs a web server on port 80, and when you hit it, it's going to show you a web page, and it's going to show you the container ID of the container that this application is running inside of. So this is cool because it lets you see as you spin it up what container it's running inside of. So we're going to run this. -p is for port. So we're going to bind a port on my machine to a port within the Docker application. So I'm going to say port 3000 on my machine is going to map to port 80 inside this container. So if I hit localhost 3000, it's actually going to route that to port 80 inside this specific container. So that's running now. There's nothing happening, but it's running. So let's come here and go to localhost 3000. We get our hello world, and this is the ID of the container that is running. Just like that. So if we come back here, oh, you can't see the bottom in this presentation. Hold on. There we go. That's better. Sorry about that. So you can now see it, and it's running in the foreground. So if I kill that now, and I refresh, there's nothing there. So we can run in detached mode with the -d flag. That's going to run it detached essentially in the background. That's my long form container ID. So now if I sudo docker ps, you can see that I'm running hello world, created 6 seconds ago. This is the short version of the container ID. As you see, it matches the first part of this long-winded container ID. So now if I come back and refresh again, now we're here, but with a different container ID than last time. So kind of cool. We can also say, let's spin up a couple of these. So now I'm gonna pick a different port, say 3001, and maybe 3002. Now I'm running 3 copies. So you can see they have different container IDs, because these are different instances. So if I come here, we have localhost 3000. I can go to localhost 3001 and localhost 3002. All of these are different instances of the same application running inside their various containers. So that's kind of the basics for Docker. You can Docker ps to get your running containers. You can Docker run to run a specific container. You can Docker kill to kill it. -d to do the detached mode. -p to specify port mapping between the two. So let's kill these. And now if I come back here, no more. There's nothing there. So now that we have done that, let's deploy this container on Kubernetes, right? So hopefully you have installed Minikube, which is essentially a localhost development testing version of Kubernetes. You also will need kubectl, which is the command line tool for interacting with a Kubernetes cluster. And I think that should pretty much be it. So we're going to first boot up Minikube. You got to run Minikube start. It's going to boot up the Kubernetes cluster, and it's going to configure kubectl to use that cluster. You can point kubectl to various clusters. So if your organization or you personally are running multiple clusters, you can set up kubectl to point to anyone at any one time. And then when you're interacting with it, you're going to be interacting with the cluster that you point it to. It can take a while because it actually boots up. Minikube does run inside a VM. Docker, not a VM, but this is running a Kubernetes cluster inside a VM, so it's a little bit confusing, but it takes a minute to start up. But what we're going to be doing is writing a deployment file that is going to contain our desired state for our application. So I have one pre-written here because they're a little bit long. It should be in the description of this video. But our deployment is going to contain 2 parts. So let's start with this deployment. We are creating a deployment. The name of the deployment is Hello World. And here's the specification. I want 5 copies of an app named Hello World. It's going to have 1 container. So this is a YAML array, essentially, containers, and then you have like dashes. Have 1 containers. It's also going to be named Hello World, and it's going to run this image, which is the image that we were running before. So it will pull down that image from Docker Hub, and it will run it, and we're going to run it on port 80 inside that container. The second part is a service. We're declaring a service so that we can access this deployment, these pods, from outside of our cluster. So we need to declare a service. It's going to be named Hello World Service. And what should it target? How will it know what pods to look at? And that's where the selector comes in handy. So we're saying this service is going to apply to any pod that has any application that has the name Hello World. Since we declared ours to have the name Hello World, then it's going to be able to know that it needs to target them. We're using TCP. And there's a couple of port options here. Now I put comments here to make this clear because it was confusing to me at first as well. There's port, target port, and node port. The port is a port to expose that is only accessible from inside the cluster. So let's say I'm running a couple of pods. They want to communicate with this Hello World pod. They would be able to do that from inside the cluster at port 8080. From outside the cluster, I would not be able to access this via port 8080. The node port is a port that is accessible from outside the cluster. This is if I hit my master node, port 30,001, now I will be able to hit the target port, which is the port to forward to the pod. So from inside the cluster, if you hit port 8080, it's going to forward it to a pod with this name, port 80. If from outside the cluster I hit port 30,001, it's going to forward it to a pod with this name, port 80. It's a little complex, but it starts to make sense when you actually see it in action. And the type is a load balancer. So it's going to load balance between these 5 instances of our Hello World application. So let's get started. Now kubectl is set up and configured. As you can see, it started the VM, it booted everything up, it configured kubectl to use the cluster, all that jazz. So we can say sudo kubectl get pods. There aren't any. We haven't actually done anything yet. Kubectl get deployments. There's not going to be any. We haven't done any yet. Kubernetes offers a really cool thing called the dashboard. It essentially is a GUI application. Sorry, what is this? Maybe I don't need the sudo. Yeah, there we go. So it's a GUI application for interacting with your cluster. If you are command line averse or you just would like a visualization, you can come in here and you can see this. So again, no deployments, no pods right now, but that will soon change. We could create it from in here, but I'd like to show you guys the command line environment just because, I don't know, it's good to be technical with it. So we are going to now use this the deployment YAML that we created. So we're going to go into that file. As you can see, I have my deployment YAML right there. So the command to create a new resource based off of a YAML file is create. -f is the file, the path to the file that you're going to be deploying. If you already have a resource created, all you have to do is change create to apply. So we're going to go ahead and set that up. So since the service was the first thing inside of our YAML file, it created the service first, then it created the deployment. So now if we come back here and we get our pods, you can see that we have 5 copies of our Hello World pod running. They each have a different ID, and they're good to go. We can get our deployments, and we have a single Hello World deployment. We want 5 pods. We currently have 5 pods. There are 5 of them up to date and 5 available. So something that's kind of cool is, check this out. If we open the dashboard in the background, we can come back here and look at our, if we can see this here again. So we have same thing as we saw in the command line. Hello world, there's 5 pods going. We can see all these pods. So our deployment says that we want specifically 5 copies of this running. So what happens, say, if one of these were to crash or go away? Oh no, now there's only 4 running, but wait, it creates a new one automatically because we were not in line with the declared state. And so Kubernetes is going to add new resources until we fulfill that state. So if I come back here and get our pods, we still have 5 running because the 1 is terminating because I deleted it. We had 4 from before, and now we have a new one that was just created to fulfill that 5th spot because I created it, or because I deleted this one. So we still have 5. And that's kind of the power of Kubernetes. Like a pod crashes, a pod gets deleted, something happens, a node goes offline, it will automatically scale up and fill, everything, create pods, create resources in order to fulfill your desired state. So let's demonstrate the load balancing. Let's get the IP address of my Kubernetes cluster that is running. And we said we wanted it was port 30,001. And look, we hit it. It's running, that's this specific container ID, which we would see if we listed the pods, and it actually knows that it's running inside Kubernetes now, which is different than what we saw before, and it knows the service that's running. So it shows port 8080 because from inside the cluster, remember, port 8080 is available. This is the IP address of the master node from inside the cluster. We are outside the cluster, so we had to use port 30,001 to hit this cluster. So there we go. But it's supposed to load balance, right? If I refresh enough, it will change, but I believe Kubernetes uses sticky load balancing. So there, you saw it change. There, it's changing again. If I open up some incognito windows, it should also change. But it is load balancing. As you can see, it's changing. It's difficult to demonstrate because it uses sticky load balancing. But you know it's there. You know it's load balancing. Pretty simple. It's running 5 copies of what we needed. We can really easily scale this, which is one of the really cool parts. So you can set it to do it based off of like CPU usage. We're just going to do it manually. So let's say we know every day 9 a.m. everybody gets to work. They're trying to log into our application, whatever our application may be. So from 8 a.m. to 10 a.m. we need more copies of our service in order to handle the load. The rest of the day it's fine, but just like specifically at that time, it's demanding. So instead of 5, we want to double it. We're going to go 10. Now, if we check it out, it says it's updating. We're not in the desired state. If we check out our pods, it's creating containers. Now we have 10 running, or they will be 10 running once they're done creating. So if I keep refreshing here, now we have 10 going. And you can see these were the original 4. Here was the one that was created because I deleted one, and now here are 5 new ones. And they're all created and running dynamically. You can also scale down. Maybe now it's after 10 a.m. We don't need all these copies. We really only need like 3. Boom, scale down. We can come check it out. It's gonna terminate pods up until there's only 3 running. It's gonna slowly remove these up until there's only 3, and you'll see it's keeping 3 alive while it terminates all the rest of them. So that's kind of the power of Kubernetes. It's really awesome. So we were using an example application, but what if we want to run our own actual application that we write and deploy it on Kubernetes? We can do that. I'm going to use kind of this example from Node.js of how to containerize and create a Node web application. This is what I'm basing everything off of. So in my file here, we are going to use Express, which is a Node package for web application. So we need to create a new directory here. We're going to initialize all of our stuff here. And now we need to install Express and save it because we're going to be using it. So we'll see that essentially our package JSON is going to look very, very similar to this. If I open this up in VS Code here, the only difference is our test script here is auto-generated, but we have our main and our dependencies is the big one. VS Code dependencies, we're using Express. So we're going to change this to start, and it's just going to be node index.js, which we now need to create. So let's come into our example app. Let's touch index.js. And I'm just going to copy what they have here. We could write it manually if we needed to or wanted to, but in the effort of saving time, I'm just going to copy what they have here to send. It's just going to send hello world on the host and port declared up here. You could do these using environment variables if you wanted. That's how a lot of the stuff is done within Docker and Kubernetes. Because you don't want to hard code some of this stuff, you do it using environment variables. So you declare database connections, hosts, ports, all that kind of stuff using either a configuration service or using environment variables. So that's what we're going to use. But now we need to containerize this. So how do we do that? We need to create a Docker file. I have one pre-written here, so I'm just going to copy the contents and explain everything to you guys. So inside here, we need to now touch Docker file. All right, so let's go over this line by line. First, from. From is always the first command inside of a Docker file, and the remainder of the line is another Docker image that our application is going to be based off of. So in this case, we're using Node Carbon. That's Node 8.9, but we can go look. So we can go to the Docker Hub, and you can search for pretty much any image you want. There's Node here. You can see these are all of the supported tags. We could use 9.0. We could go all the way back to 4.8.5 if we really wanted to. But one of the kind of cool things is you can see Docker files, since my application is going to be based on Node. Node has to be based on something, right? So let's check it out. In here, we can look at the Docker file for Node, and you'll see that the first line in here is from build pack dependencies Jesse. Okay, well then we can go look for that. What is that based off of? Build pack deps. I spelled it wrong, but here it is. Okay, and it was based off of Jesse. So what is this? Common build dependencies using for installing various things. All right, Jesse. Jesse is based off of Jesse SCM. Jesse SCM is based off of Jesse curl. Jesse curl is based off of Debian. So we're using a Debian image, which has this build pack dependencies, which contains a lot of just libraries and dependencies, which then Node uses to build off of that, and then we're building off of Node. So it creates this layer of Docker images that everything is built up off of. One of the really cool parts of this is that then when I'm building my image, and you'll see it when we actually end up doing this, it's going to show those, you'll see that there's going to be like, I think 6 or 7 layers to mine. But in the future, if I were to rebuild the layers, it actually is going to I think it hashes those layers to determine if they've changed. And if not, it won't actually even update the previous layers. It essentially creates this caching based off of hashes to determine if a layer has changed, and then it can just plug in a layer instead of having to rebuild the entire thing. So the first time I build it, it'll probably have to do everything. But in the future, if I rebuild it, it won't have to build up the Debian and the build pack dependencies and the node. It'll just plug in the existing copies of those layers and then just rebuild my image, assuming that I change it. All right, so from Node Carbon. Inside our container, what is our working directory going to be? We really could declare pretty much anything, but it's common to put it inside user, your user directory, because you're not going to be interfering with anything else inside the container. We need to copy over our package.json. And one thing that I need to do, I didn't look, what version of Node am I running? Okay, so npm. All right, so I'm on an old version, so I don't actually have the package lock. But let's update just for the heck of it, because we're using 8.9 here, so we should probably be using it. So npm version 5 and above introduces a new concept called the package lock. I actually wrote a blog post on Medium about it. You should find that and read it if you're interested in what package lock is and what it does and why it's important. So to demonstrate it, we're going to use that. So we need to run npm install again, and it'll generate the package lock for us. So we need to copy the package.json, but we also need to copy the package lock.json. And that is important if you are using npm version 5 and above. You should be copying your package lock as well as your package.json. Now run a command. What are we going to run? npm install. So now inside of our container, inside of the working directory, we're going to install all of the packages that we need to run our application, which are declared in our package and package lock. Then we need to copy the remainder of the files, expose a port, 8080 in this case, and then the command is when I run my image, after I've built my image, when I actually say docker run, my image, what is it going to do? And the answer is it's going to run npm start, because npm start just runs node our file, and then it will create our server. So you might say, well, why would I want to copy the entire source into over there? Like, what about the node modules or any debugging stuff? I don't need that in there. That's just going to make my image bigger. And that is where you are correct. So we're going to create a docker ignore, very similar to a git ignore file. And we're going to ignore the node modules so that when it copies everything, it's not going to copy the node modules, because those are going to be installed here. And if we had other things that were important maybe for developing, but not for the production application, you could also put those in your docker ignore, and then we wouldn't, they wouldn't be copied over into your container when it gets built. So that's all you need for a Docker file. You need your from, you need to establish your working directory, do any commands that you need. That's essentially the section. Any commands that you need to build your application, copy your files into the container, expose the port that you want it to expose if you need it, and then a base command that will be run. This is an array because the first argument is the actual name of the thing, and all subsequent arguments or elements in the array are arguments that would be passed. So if I wanted to pass extra flags or anything, I could just add elements to this array and it would do it. So now we need to build this Docker file to then run it. So we can say docker build -t is going to be our target. What are we where are we targeting? Or sorry, -t is the name of the Docker file that we're building. So I'm going to use my Docker account. This is going to be example app version 1.0.0. We're going to build it, and then the last argument is the path to the Docker file. Since it's in my current directory, I'm just going to put dot, and that should be able to go. So you'll see, here we go, our steps, our layers. Let me pull this up here a little bit. So, our first layer is going to be like the scratch layer from base. Then you're going to have the Debian Jessie. Then you're going to have the build dependencies curl, build dependencies SCM, build dependencies Jessie. Then you're going to have node. Then you're going to have my application. And evidently there's one more in there that I missed. But essentially that's what it's doing. It's downloading each layer and it's building them up and it's compiling them into the image that can then be run on any machine that also has Docker. So the first time, as I said, it's going to do this all and it's going to take a little bit. But if I were to make a change and rebuild, it would actually take significantly less time because it would only have to do the layers that changed, which would be my code, not all these previous libraries that already exist. So now it's running our Docker file. So that was just downloading the previous layers. Now it's actually running. So you can see it established our work directory. It copied over our files. Now we're running npm install. We copied over the rest. We exposed the port and we set the command. Now it's built. So if I want to run this, we're going to run, we can port 8080 to 8080, again mapping our local host port 8080 to port 8080 inside the container. And we're going to run example app. I don't know if this will still be up on my Docker hub when you, viewer, are doing this. You can try to use mine if you want. Just substitute my name for your Docker account, and it should just work just fine. So if we run this, we see it's running our container. If we now go to localhost 8080, we get hello world, which is exactly what we expected because it's what we declared in our index. When you hit just this, print hello world, and we saw that it logged this running on the host and port. So we've built up a node application. Obviously yours is going to be more complex, different than this, but the steps remain the same. We wrote our Docker file. We now have built our application. So let's run it on Kubernetes. Yeah. So all we have to do really is just change our deployment YAML here a little bit. I'm going to kill that application. And now let's switch this up. So this is our own Hello World service, but I'm going to change this to example service because we already have the Hello World. We're going to be targeting any pods that have my app as the thing. We want to target port 8080 because we are using 8080 in here and in our Docker file, port 8080. We're going to switch these up because we were already using these for the Hello World service. So we're going to say 8081 and 30002 because we can't duplicate ports. And here we go. So let's switch this up. So this is going to be my app. Let's run 5 copies of it. Let's name this something different. Let's actually call this my app deployment because this is the name for the deployment itself. This is the name for the selector for the pod. The container name is we'll call it my app, and again, as we said, we're going to run James Quigley example app and container port 8080. Now, if I did everything correctly, this should just work. So let's try it. sudo kubectl create. Actually, I need to go back into the main directory. Sudo kubectl create deployment YAML. Helps if I spell create correctly. All right, it's going to create our service. It's going to create our deployment. Let's check out our dashboard. We can now see that's why. Important step. We created the image and we built the image here, but we did it locally. So it's stored on my local machine, that image, but I never actually pushed it. So I can quickly, let's see, we got to push James Quigley / example app v1.0.0. So now it's going to actually push this up to Docker Hub. So if we go onto my Docker, we'll be able to see a list of my repositories, and you can see a few seconds ago I just pushed example app, and the only tag is going to be v1.0.0. So now it's available publicly. So let's come back and try to redeploy our thing. Let's do apply here, and I'm actually going to specify the exact selector that we want here. If you don't specify the tag, it's just going to pull the latest. So we're just going to tell it this one specifically. All right, so let's try this again. Minikube dashboard. Close some of these out here. All right, so our deployment. We have my app deployment. If we check out our pods, these were the failed ones from before, so it was kind of flopping there. But now it's creating new ones here based off of the new deployment. So if we give it a minute, in theory, it should be working. It has to download the image from Docker Hub. So the first time you run it, it can, it might take a little bit of time. You can change that policy based off of whether you want it to pull only if it doesn't have the image, if you want it to pull from Docker Hub every time. Yeah, that's totally like optional based off of what you want. I'm gonna delete these just to like make sure that they get cleared out. That shouldn't be a problem. Kubernetes should handle it, but it seems like it thinks these are live, and so it's not creating new ones. So eventually it would have figured it out, but in the effort of speeding stuff up, I'll do these manually. So 1, 2, 3, 4, 5. It's creating those containers. Thought I've already deleted these. All right, so here we go. Some of them are up now. So if we hit, let's get the IP address again because I don't remember it. If we hit port 30,001, this is the old port, remember, we should get the Tudum Hello World. That's running inside of our cluster. If we hit port 30,002, we get Hello World. We get our application running inside of our Kubernetes cluster here. It's still finishing this. Here we go, and it's done. So yeah, you have 5 copies of it. They are being load balanced. We don't necessarily have a way to tell that, but they are. They are being load balanced within our Kubernetes cluster. So yeah, I mean, now we've gone over Docker, we've gone over microservices, we've gone over Kubernetes. We ran examples within Docker. We created our own Docker image, Docker file, and then built the image from that. We deployed all of those things onto Kubernetes, so you could see the power of load balancing, dynamic, scaling, automatic deployments, that kind of thing. And that's pretty much everything that I have today. So if you have any questions, you can contact me. I'm on all of the social media sites, on Slack for Computer Science Club and for Soda. And you can always reach me by email or tweet at me. I am not an expert on these things. I just love the technology, and I'm trying to use it and inform people about it as much as I can. But I will always do my best to help. So I hope you enjoyed the presentation today, and have a great rest of your day.